Hello everyone. For my part of the deep learning assignment, I implement an artificial neural network model to predict house purchase decisions using the global house purchase decision dataset. First, I cloned our GitHub repository and loaded the preprocessed data. The data was already split into training and testing dataset and stored as NumPy arrays. Next, I designed my ANN model using TensorFlow and Keras. The architecture starts with an input layer that matches the number of features followed by a dense layer with 1 to 8 neurons and rule function, a dropout layer to reduce overfitting, another dense layer with 64 neurons and badge normalization, then a 32 neuron layer, and finally a sigmoid output layer that predicts whether a person will purchase a house or not. I complete the model using the Adams optimizer with a learning rate of 0.001 and binary classification entropy loss, since this is a binary classification problem. For training, I used early stopping and reduce LR on callbacks. These help the model to stop automatically when validation loss stop improving and reduce the learning rate to fine-tune performance. The model was trained for up to 25 epochs with a batch size of 1 to 8 using 80 to 20 validation. After training, I evaluate the model on the test data. It achieved an accuracy about 87.6% and RCO score of 0.9269, showing very good classification performance. The classification report also showed high recall for the positive class, meaning the model effectively identifies potential house bias. Finally, I plotted the training and validation accuracy and loss curves, which confirmed that the model was well balanced and not overfitting.
Hello everyone, my name is WSL Priyantha and my registration number is IT22028846, and this is my deep learning project for the SC4050 module. I used the global house purchase dataset to predict whether a person will purchase a house using an LSTM model. First, I loaded the pre-processed NumPy data files, training and testing set for input and labels. The data was resharped into a 3D structure with samples, timestamps, and features which is required by LSTMs. I verified the shapes to confirm the data was ready for training. Next, I built my LSTM model in TensorFlow and Keras. It has two stacked LSTM layers with 64 and 32 units, both using the TANH activations. Dropout layers help reduce overfitting. Then a dense layer with ReLU activation learns higher level patterns, and a final sigmoid layer outputs binary predictions. I compiled the model with the Adam optimizer, binary cross entropy loss, and tracked accuracy and AUC. Training used early stop in and reduce LR on Plato callback for better convergence. The model trained for about 15 approaches with a validation split of 20%. On the test set, the model achieved an accuracy of 0.8757 and ROC-AUC of 0.9220. From the classification report, class 0 had perfect precision and class 1 had perfect recall. The graph show that both training and validation accuracy stabilize around 0.88 and the loss decrease smoothly, indicating good learning and minimal overfitting. Overall, my LSTM model performed very well for this data set, showing strong predictive power. That's all about my model. Thank you.
I am going to explain the part of our project where I implemented the RNN model to predict house purchase decisions. After importing the required libraries, first I used the preprocessed dataset that was already cleaned and normalized and saved as .mpy files. Then loaded the training and testing datasets from data directory, and each sample includes 10 numerical features. Next thing I did was building the RNN model architecture using TensorFlow Keras sequential API. The first RNN layer has 64 units with tanh activation function, which learns short-term relationship between features. And a dropout layer of 0.3 was added to prevent overfitting. Then I added another simple RNN layer with 32 units for deeper sequence learning, followed by another dropout layer. After that, I used a dense layer with 64 neurons and a ReLU activation to learn nonlinear relationship between features. Finally, the output layer um, has one neuron with a sigmoid activation, which performs binary classification, predicting whether the customer will purchase a house or not. Then I compile the model using Adam Optimizer with a learning rate of 0.001 and use binary cross entropy loss and accuracy with accuracy and AUC as performance metrics. Uh, For training, I used 30 epochs, batch size of 1 to 8, and included early stopping and reduced LR on plate callbacks to prevent overfitting and improve training stability. And after training, I evaluated the model using test dataset. The model achieved a good accuracy of 0.87587 and a ROC AUC score of 0.92393. Showing that it could effectively identify purchase decisions based on the customer and property features. Finally, here I plotted the accuracy and loss curves to visualize training progress and then save the trained model and its metrics in results folder for later comparison with other models. In summary, the RNN model here used successfully captured the sequential relationships among numerical features.
Hello everyone, my registration number is IT22027306. Our assignment focused on supervised classification problem predicting a house purchase decision from the global house purchase dataset. This dataset contains mix of numerical and categorical features like price, salary, and country. For this task, I implemented a 1D convolutional neural network, which is typically used for sequence data but can be highly effective for extracting features from a structured tabular dataset. The core challenge was transforming this structured data. After handling missing values, I applied one-hot encoding to categorical features and min-max scalar to numerical columns. Crucially, I then reshaped our data into 3D tensors. This treat each customer features as a sequence, allowing the 1D function to search for local patterns or relationships, for instance, between loan amount and down payment, a significant average over standard dense network. My model uses a sequence architecture. The first layer is Con1D with 64 filters and a kernel size of 3, designed to scan 3 features at a time to learn local dependencies. This is followed by batch normalization for training stability and max pooling 1D to downsample the make the features more robust. A second deeper Con1D layer with 128 filters further refine the features. We then use global average pooling to efficiently condense the learned features before passing them to the dense layers. A dropout layer of is included to prevent overfitting. Finally, the output is a single neuron with a sigmoid activation to output the purchase probability. The model was compiled using a Adam optimizer and the binary cross entropy loss with is which is standard for classification. We also monitor for accuracy and AUC. To ensure efficient training, I use two callback functions. Early stopping to half training if the validation loss doesn't improve after 5 epoch and reduce the Laurent plateau to adjust the learn rate dynamically. The training ran for a maximum of 25 epoch with a batch size of 128. The final evaluation on the test set yielded a strong result, an overall accuracy of 87.4% and excellent ROC AUC score of 0.925. The classification report reveals a high recall of 97% for class 1, meaning the model is very good at identifying potential bias, though it has a lower precision of 65%. Looking at the performance graph, the accuracy plot shown both training and validation curves rising smoothly and staying close, indicating the model is learning well without significant overfitting. Similarly, the loss plot demonstrates a clear and steady decline, validating that the early stopping successfully found the point of optimal performance before divergence. In conclusion, the 1D CNN successfully leveraged the sequential nature of the tabular features to achieve a high-performance purchase predictional model. Thank you very much.